Hi, chemistry students. Thanks for being patient with me. This is Mrs. Allgood. This is my first attempt at making videos, and I'm having fun, and I hope you will too. We're on page 2 of 6 of our notes packet today, and we're going to talk about some characteristics of solutions. So some of the things that you are going to need to know about solutions are that solutions are substances that are called soluble. In other words, they're capable of being dissolved. Also, substances that are incapable of being dissolved are called insoluble. That's going to be important when we start talking about our solubility rules. Number 3, the dissolving medium in a solution is called the solvent. This is the one that's doing the dissolving. Okay. And I'm going to get a highlighter here. And so usually, but not always, we have that as water. You know, water is a great dissolver, but sometimes it doesn't dissolve everything. All right, so there's my highlighter. Usually water. All right. So the substance that's being dissolved in a solution is called the solute. Okay? So what's being dissolved is solute. What's doing the dissolving is the solvent. Number 4. We've done. Number 5. Solutions may exist, get this, as solids, liquids, or gases. They don't always have to be liquids, so that's kind of neat. And 2 more terms that you will need to know that pertain to solutions are miscible and immiscible. You might think they're opposite, and you're right. Miscible liquids are able to dissolve freely into one another, and immiscible liquids are not soluble in each other. So you can think about maybe Mio. Mio in water is that little drink enhancer, and it's put in water, and they dissolve freely together, water and Mio. But immiscible liquids are things like oil and water. They're both liquids, but they don't seem to like to dissolve. So these often refer to only liquid and liquid solutions. All right, now here is a list of some types of solutions. First of all, we have types of solutions that can be just a gas and a gas together. An example of this is air. Air is made up of several different types of gases, and they're mixed together. Sometimes unevenly, it depends on where you are. Another type of solution is a gas and a liquid. An example of this is, of course, soda, kind of drink. We don't like to drink flat soda. We like the gas in it. Liquid and liquid, an example of that, believe it or not, is vinegar. Vinegar, you know, vinegar has this acid in it called acetic acid. I apologize for my writing tool. I will get better. But vinegar is a mixture of 2 liquids. All right, we can all think of something that's solid that we dissolve in liquid. How about a solid and liquid? Oh, dental filling. Well, of course they change things a lot, but used to they put mercury in your dental fillings. You know, mercury was is now known to be poisonous, so they don't do that so much anymore. So the solute was a liquid, the solvent was a solid. Interestingly enough, this sort of solute was the mercury, and they put it in a metal or some other type of substance. Here's the solute here being a solid, and here's the solvent being a liquid. What about saline? Saline's used for a lot of different things. Saline. My, gonna have to do better with my writing. So a saline solution would be something you would use maybe for contact lens. So that would be like salt dissolved in water or some other type of liquid. And then the last type of solution might be sort of a solid solute again, but this time that solid solute dissolved into a solvent that was solid. I always like to think of chocolate, but you know, you got this 10 karat gold thing too. 10 karat gold or any other alloy of metal. Yeah, buddy. 10 karat gold would be the example for that. So that's AU. So an insoluble solid that happens to collect at the bottom of a solution is what we call a precipitate. Precipitate. Let me see if I can make this better. I think I can. Yeah, precipitate. That way that gives you the word. Yeah, so we're just going to make that smaller. So a precipitate is one of those things that settles out to the bottom of a liquid, and it makes it kind of cloudy looking. Rubbing alcohol and water are miscible. And how about determining whether or not oil and water? What do you think? Is it miscible or immiscible? Definitely immiscible, right? Because we said that earlier. Okie dokie. So, on to the next part. So, like dissolves like. Like dissolves like. So what that means is that polar and ionic solutes dissolve in polar solvents. Very important. So like dissolves like. And again, if you have a non-polar solute, it will dissolve in a non-polar solvent. Most compounds are either polar or they're ionic. Water, of course, as we said earlier, is a polar solvent. Therefore, water is a universal solvent. We have said that before, and I think that you'll remember that it is a universal solvent because it's unique to the universe. We don't have, or our universe rather, we don't know of any other place in the universe that has water. Rate of dissolution. It refers to how quickly a solute dissolves, and we'll talk about that in more detail when we talk about some solubility curves and at what temperatures they can dissolve. And then the last word here, solubility. Again, this is the state of being dissolved. It refers to the amount of solute that can be dissolved at a specific temperature. And we can look at both of these in graphs that make our life easier and we can understand. All right, so what are some ways, or what could affect solubility or the rate of dissolution? Well, here are just some ideas that you will want to memorize. First of all, you can heat it, you can agitate it, meaning you can stir or shake it. You know, you do all this in the kitchen. You can increase the surface area if you want to dissolve it, meaning you can crush it or grind it. And one other way that might be able to work in a gas only is to increase the surface pressure. So let's see what happens. So if you heat it, one of the things you've learned, if you heat up, you heat up your iced tea, it's definitely going to dissolve the sugar a lot easier. So we know that solids can dissolve things if the solvent, if the solution is heated up. But it decreases the solubility of a gas. All right, so what if we agitate it? Let's take a Coca-Cola can, let's shake it up. It's going to definitely increase the solubility of the sugar. The sugar is going to dissolve. Not going to have much effect on the solubility of a solid, but it's going to decrease the amount of gas because, as you know, that Coca-Cola will just sort of allow the bubbles to start to come to the top. Okay? Dissolution rate of a solid. Let's talk about crushing or grinding it. What happens? It increases it. You make a lot of surface area, you grind up the sugar into small parts. It's going to increase the rate of that solid to be dissolved. So what about the solubility, the dissolvability of a solid? No effect, and you really can't crush or grind up a gas. And then the last one is increasing the surface pressure of a solution. There's no effect on the dissolution rate of a solid and no effect on the solubility of of a solid, but it does increase the solubility of a gas. All right, thanks for watching, and we will have 3 more videos coming up. We're going to start on page 3 of the next section of your notes. We'll take a break and we'll come back.